Let's look at the following two fractions. If I have 5 over 8, we said that we can write this as a decimal. So to do that, I'm going to use my calculator. I'm going to say, what is 5? What is 5? Oh, let's switch it on. Clear. 5 divided by 8, and my answer is 0.625. Let's take another number. Let's take the fraction 1 divided by 3. And we do that in our calculator. Clear. 1 divided by 3. Enter. And I see my answer goes on and on and on and on and on. And the only reason it stops here is because we run out of space. Now, you should know by now that this is called a terminating fraction or terminating decimal. Terminating because it stops. And this one is recurring. So there's a pattern. And the pattern recurs. And then just quickly, I want to show you why this happens. So you've got a better idea of what we're going to do about it. If I take 5, if I say I have 8 to the 5 divided by 8, it means that I have 5 here, and I divide 8 into that. 8 does not go into 5, so that's a 0. And what I do then, I put a decimal place, and I add a 0. And I say 8 goes to 50 6 times. 6 times 8 is 48. 50 take away 48 is 2, so we just keep on adding zeros. So if 8 goes in, 6 times 8 is 48, 50 take away 48 is 2. 8 goes into 20 twice, 2 times 8 is 16, 4 remains. 8 goes into 40 exactly 5 times, and that is where the fraction terminates. So we can see why this is terminating. Why is this recurring? If I'm going to and say 3 divides into 1, and I'm going to put my couple of zeros there. 3 divides into 1 0 times, there's my decimal. 3 goes into 10 3 times. 3 times 3 is 9, 1 remains. 3 goes into 10 3 times. 3 times 3 is 9. 10 take away 9 is 1. You can see why this will just keep on happening, because we will keep on adding zeros and the same pattern just happen over and over and over again. So that is why some decimals are terminating and some of them are recurring. Now with terminating fractions, it's pretty easy to just write them down. But with recurring, I would like, if I put this into a document, I would like people, the reader, to know that this is a recurring value. So to indicate that it's a recurring value, there's 2 different conventions that we use. So conventions is just sort of a habit of how to write it, so the way that we always do it. So if I have something like 0.555555, there's 2 ways of showing this. I say 0.5, and what I do is I put a dot on the first number that recurs. So that will be a dot over there, and that will show that it is 0.5 and the 5 recurs. If I have a value like 0.3412412, I see that it's not the first one that recurs, but 412 recurs over and over and over. So if I want to write that as a recurring value, I'll say that equals 0.3412, and I put a dot on the first value that is in the sequence and the last one in the sequence. So it means this is 0.3, and from 412 we'll repeat from 4 ending to 2 will repeat again and again and again. So that is one way of doing it. The other way of doing exactly the same thing, so if I have 0.5555, we can use, instead of a dot, we can use a line. So we can say this is 0.5, and to show that it's recurring, you put a line over the 5, only over the 5. And if it's 0.3412412, you say that is 0.3, and you write the first sequence down, and we say this part repeats. So any one of those two is good to go.